Good evening, dear viewers. I'm continuing the statistics class today. Yesterday we completed the range and interquartile, semi-interquartile range, that is quartile deviation. Today I'm going to take you for the next two methods, that is mean deviation and standard deviation. Mean deviation, that is we have to calculate the average and from that we have to take deviations. That's why it is known as mean deviation. And when we are going for mean, we can use arithmetic mean or the positional average median as an average. And when we take deviations from the arithmetic mean and median, one thing you have to observe is the deviations taken from arithmetic mean will be more than deviations taken from median. But we have to take into account, we have to take into account the arithmetic mean, and from that we have to take into account the deviations. Okay, now what is the formulas that we come across when we go for mean deviation? Here you have to observe one thing. When you are taking deviations from arithmetic mean or median, whatever it may be, the average, we should not take into account the signs. That is, we have to ignore the signs. Whether you come across positive signs or negative signs, you have to take them as positive signs only. You should not consider about the negative signs. All the deviations, whatever you have taken, you have to consider that as positive deviations only. Mean deviation. First of all, you have to calculate, I told you already that first of all you have to calculate arithmetic mean or median, whatever it may be. You may ask me, sir, why don't we take the other three? You can take, but thing is, regarding calculations part, it will become very tough because mode is the highest number of occurrences of a data. So we have to take into account the mode value, we have to derive the correct mode value, and we have to take deviations. And geometric mean and harmonic mean, we should not take into account that thing, because geometric mean is the nth root of product of n items. So we have to use the logarithms. And harmonic mean is nothing but the reciprocal of the variables. So when we are going for geometric mean and harmonic mean, the calculations part, it will take into account more, and it is nothing but a time consuming aspect, and those things, that is mode, geometric mean and harmonic mean, they are used for other studies, that is further studies apart from UZ. When you go for PG classes, then we can consider this mode, geometric mean and harmonic mean. But up to UZ standard, only arithmetic mean and median, they are used. Individual series. MD is equal to sigma mod D by N. What is this sigma mod D? D within parallel lines. Actually, we will call that thing as modulus. Modulus D by N. What is mod D, sir? Deviations taken from arithmetic mean or median ignoring signs. That is nothing but mod D. Deviations taken from arithmetic mean or median ignoring signs. It is nothing but mod D. So under individual series, the mean deviation is equal to, this I am talking about the absolute measure, please. I am not talking about the relative measure. Absolute measure of dispersion when we are going for mean deviation. MD is equal to, mean deviation is equal to sigma mod D by N. That is, we have to calculate arithmetic mean or median, and from the variables we have to take the deviations, and we have to consider that all the deviations are positive deviations. Even though we get negative deviations, we should not consider them as negative deviations. We have to consider them as positive deviations, and we have to total them, and we have to divide with the number of observations. Now coming to discrete series, MD is equal to, sir, what is the coefficient, sorry, what is the relative measure? The relative measure or coefficient of mean deviation is equal to mean deviation by arithmetic mean or median. That is nothing but the relative measure. Okay, now coming to discrete series, mean deviation is equal to sigma f mod d by n, or sigma f. That is, we have to take into account the frequencies, and we have to multiply the frequencies with their corresponding mod d's, deviations taken from arithmetic mean or median, and we have to total them. So you will come across sigma f mod d, and n is equal to sigma f, or total of frequencies. This is about the absolute measure when we are going for mean deviation. Now what is the relative measure, sir? The relative measure is mean deviation by arithmetic mean or median. That is the relative measure of dispersion under mean deviation. Now coming to this continuous series, mean deviation is equal to same as sigma f mod d by n, or f sigma f. Here one thing you have to observe is, when you go for continuous series, you will come across class intervals. So you first of all you have to calculate the mid value or middlemost point. Mid value L plus u by 2, that is nothing but midpoint or mid value. So we have to take into account, we have to calculate the mid values or midpoints, and from that, from that you have to take into account the arithmetic mean or median. So thereby you will come across deviations, and all the positive deviations or negative deviations we have to ignore, and all the deviations we have to consider them as positive. And this mod d, whatever we can derive, that must be multiplied with the frequencies in order to get f mod d. Then we have to add all the f mod d's, and we will come across sigma f mod d by n, that is sigma f. So this is how you will come across. Here also the relative measure is mean deviation by arithmetic mean or median. The same rule, right from individual series to discrete series, the same rule will apply. This is about the mean deviation. Next comes the very, very important one in dispersion, that is nothing but standard deviation. Standard deviation. It is represented by sigma. Here sigma means two things. One represents standard deviation, one represents the summation. Both the things we will call them as sigma, but the writing, when we are writing, they are entirely different. Now when we go for standard deviation, what is standard deviation, sir? It is square root of deviations taken from arithmetic mean only. Here we are not using median, mode, geometric mean and harmonic mean. We are taking deviations from arithmetic mean. And we are calculating. That is nothing but square root of, mind it, square root of product of deviations taken from arithmetic mean. That is nothing but standard deviation. And when you go for standard deviation, again it will have some different methods, like how you come across an arithmetic mean. That is direct method, indirect method, or shortcut method. When we go for direct method under individual series, sigma, that is standard deviation, is equal to square root sigma x square by n. Here whatever it may be, the deviations that we come across, we have to square them. Then we have to find out the square root. Okay, that's why standard deviation is nothing but square root of squares of deviations taken from arithmetic mean. Okay, here the direct method, standard deviation is equal to square root of sigma x square by n. Okay, here x is equal to x minus bar x. That is compulsory, we have to calculate arithmetic mean and we have to take deviations, okay, from each individual variable with the arithmetic mean. There you have to take into account positive deviations and negative deviations, and when we are squaring all the positive deviations or negative deviations will be converted into positive deviations only. Okay, that's why we have to take into account standard deviation is equal to square root of sigma x square by n. Then we have to take into account the squares and we have to total the squares. So that is nothing but the direct method for calculation of standard deviation under direct method. Now what is the indirect method or shortcut method? Here we have to take into account one value as assumed mean. One value as assumed mean. That is, it is not an actual mean, please. We are assuming one value as assumed mean, and from that assumed mean we have to take the deviations and then we have to square the deviations. So the formula shortcut method or indirect method is square root sigma d square by n minus sigma d by n whole square. That is, for n also there is whole square, please. Once again I am repeating. Okay, standard deviation is equal to square root d square sigma d square by n minus sigma d by n whole square. That is, we have to take into account n also the square root. And how we will get the deviations? X minus assumed mean a. X minus assumed mean a. We have to take into account assumed mean. It is not an actual mean, it is an assumed mean. And this assumed mean, there is no necessity for you to take from the data. You can take any number and that thing we have to assume that as arithmetic mean. That's why it is known as assumed mean. So x minus a is equal to d. So we have to take into account the squares of the deviations and then we have to add and we have to do this. Standard deviation is equal to sigma d square by n, sigma d square by n minus sigma d by n whole square. So this is about the individual series. Now coming to discrete series. There also you will come across two methods, direct method and indirect method, which is also known as shortcut method. Okay, now in discrete series, what is the difference? We'll come across frequencies. So standard deviation is equal to sigma fx square by square root sigma fx square by sigma f. Okay, square root sigma fx square by n or sigma f. Here what we have to do is we have to calculate arithmetic mean and we have to take deviations, and these deviations we have to square them. And after getting the squares we have to multiply with their corresponding frequencies and we have to add in order to get sigma fx square. Okay, then we have to add the frequencies, that is sigma f, and we have to apply in the formula, that is standard deviation is equal to square root sigma fx square by sigma f. That is the formula. Okay, now we are going for shortcut method or indirect method. Here also we have to take into account the assumed mean. Okay, assumed mean, that is one value we have to consider that arithmetic mean and we have to take deviations and we have to square them. So the formula is standard deviation is equal to square root sigma fd square by n minus sigma fd by n whole square. Okay. Square root sigma fd square by sigma f minus sigma fd by n, that is sigma f whole square. This is the formula to calculate. That is, we have to take deviations from assumed mean, and that deviations we have to square, and we have to multiply with corresponding frequencies, and we have to do the problem. One thing here, you have to calculate f into d. That is, first of all, we have to take deviations, and we have to multiply with corresponding frequencies in order to get fd. So fd square, how we will get, sir? Fd into d is nothing but fd square. Fd into d is equal to fd square. So like this, you have to calculate, you have to calculate the deviations, and we have to add. Okay, both sigma fd as well as sigma fd square you have to add. Okay, that's why you'll come across the formula standard deviation is equal to square root sigma fd square by sigma f minus sigma fd by n whole square. This is the formula that we will come across when we go for discrete series under shortcut method. Now coming to continuous series method. Continuous series. Here you will come across three methods. What are the three methods, sir? Direct method, indirect method, and step deviation method. Step deviation. So what is this step deviation method? In order to reduce the deviations values to smaller numbers, we have to multiply with I or C, common interval. Okay, common difference or class interval, I or D. And in order to get the original value, you have to multiply after taking this. Okay. Now, continuous series direct method. Standard deviation is equal to sigma fd square by sigma f, where d is equal to m minus bar x. Okay, in continuous series, we will come across classes. So first of all, what we have to do is we have to find out the mid values. Then we have to calculate the arithmetic mean. Okay, the arithmetic mean. Sir, how we calculate, sir? Bar x is equal to sigma fm by n. Okay, using shortcut method. Direct method, not shortcut method, direct method. Some people, they will go for shortcut method. That is a plus sigma fd by n. That thing also you can apply. But easy thing, easy way is equal to, you have to go for direct method. So after getting the bar x value, you have to take deviations. That is m minus bar x. You will come across the deviations. And that deviations you have to square, and you have to multiply with their corresponding frequencies. You have to find out the product. Okay, and you have to total that. Sigma fd by fd square by sigma f. That is nothing but the direct method under continuous series. Now coming to shortcut method or indirect method. Shortcut method or indirect method. So standard deviation is equal to square root sigma fd square by n minus sigma fd by n whole square. Okay, there d is equal to, again I am telling you, m minus a, assumed mean. When you are going for shortcut method means, okay, compulsory a value we have to find out. That is assumed mean value you have to find out. And this assumed mean, it should not be in the data. You can take any number, and that number you have to consider that assumed mean. So the formula is standard deviation is equal to square root sigma fd squared by n minus sigma fd by n whole square. This is nothing but the shortcut method. And the third method I told you already in the beginning. Okay, whenever the deviations are small, we can use direct method or shortcut method. But whenever the deviations are more, it becomes clumsy and complex and time taking aspect. That's why we have to go for step deviation method. In order to reduce the deviations from bigger values to smaller values, we have to divide with I or C, class interval or common difference. Okay, whatever it may be. Now, the formula is standard deviation is equal to square root sigma fd dash square by n minus sigma fd dash by n whole square into I. In order to get the original value, we have to multiply with I. Previously, we had divided with I. Now, in order to get the original value, we have to multiply with I. Because previously we have divided. We are dividing with I. Now, to get the correct value, we have to multiply with I. So, once again, I am repeating the formula. Standard deviation is equal to square root sigma fd dash square by n minus sigma fd dash by n whole square into I. Here d dash is equal to m minus a by I. M minus a by I. That is, we have to divide with class intervals. This is nothing but the standard deviation under step deviation method in continuous series. Now, coefficient of standard deviation. Okay, coefficient of standard deviation is equal to standard deviation by arithmetic mean. That is sigma by bar x. That is nothing but coefficient of standard deviation. Now, another thing is we have to take into account two value distributions, and we have to find out, okay, which distribution is more variable and which distribution is more consistent. In this case, I am going to give an example. For example, there is a cricket test. In that, you will come across two innings. Take two Indian players, okay, whomever it may be. For example, okay, Yadav and this the Rohit Sharma. Okay, so Rohit Sharma, what he had done is he's duck out in the first innings and made 100 runs in the second innings. And Shivkumar Yadav, he did 50 runs in the first innings, and again second innings also he did 50 runs. There, if you take into account the average is one and the same, 50-50. But when you take into account the covariation or the difference, here Shivkumar Yadav is more consistent than Rohit Sharma, because in both the innings he had made 50-50 runs, so he is more consistent. So for that, you have to find out the covariation in order to find out which series or which distribution is more consistent and which distribution is more variable. So for that, we have to take into account coefficient of variation, CV. Coefficient of variation, CV. And mind it, that coefficient of variation will be in percentage. So what is the formula for calculating coefficient of variation? Standard deviation by arithmetic mean into 100. Whenever you are multiplying with 100, automatically you will come across the percentage. Okay, so standard deviation by arithmetic mean into 100. There you will come across the percentage value. Thereby you can be in a position to know who is more consistent and who is more variable. That distribution whose coefficient of variation is less, that is more consistent, more homogeneous, and less variable. And coefficient of variation for which distribution it is more is great variable and less homogeneous, less consistent. Like this you have to identify. Okay, don't forget this. Okay, whenever you go for coefficient of variation, for which distribution the coefficient of variation is less, it is more consistent. It is more consistent, more homogeneous, and more stable, but less variable. Okay, and quotient of that distribution which is more, it is more variable but less consistent, less stable, and less homogeneous. Like this, you will come across the coefficient of variation. With this, I'm stopping the class, and remaining class I'm going to continue tomorrow. Until then, have a nice day, and don't forget to subscribe to my channel. Your subscription is nothing but a encouraging or inspiration to me. And again, I'm telling you, those people who want to take online tuitions, okay, I had given my number in the previous class, and again I'm giving my cell number 9849238902. Please contact this number and have a nice time, have a nice coaching. Okay, thank you. Please don't forget to subscribe. Okay, thank you very much.